In this video, we're going to derive the formula to calculate the volume of revolution of a curve revolved around the y-axis, and then I've got one example. Okay, very similar to the x-axis, so I don't want to spend too long on this video. So, let's say we've got xy plane. We've got some kind of function, y equals f of x. And what we're going to do is we're going to take some area between the curve and the y-axis, and we're going to rotate that around the y-axis to create a volume of revolution. In our previous video, what we did was we did an area under the curve and we rotated that around the x-axis, and I derived that formula in a bit more detail. So I'm just going to state this formula, but it's the same derivation, and it is the volume around the y-axis is going to be equal to pi times the integral between two y limits this time of x squared dy. Okay, it's exactly the same formula, except the x's and y's have swapped positions. Okay, so that's what we're going to be using in this video to solve this question. All right, so here's my one example I've got on this. The region bounded by the curve y equals e to the x, the y-axis, and the line y equals e is rotated 360 degrees about the y-axis. And we're going to calculate the exact volume of revolution of this shape. So this area here is going to be revolved around the y-axis. Okay, so plugging it into the formula, volume of revolution around the y-axis, that is equal to pi multiplied by the integral of my two y limits, which in this case are 1 and e, of x squared. Now, the equation is y as a function of x, so I'm going to need to make x the subject. X the subject is just taking logs of both sides, and I end up with x is equal to the natural log of y. So x squared, therefore, is the natural log of y squared. I know some mathematicians will write ln squared y. I'm not going to do that. I think it is a bit sloppy. Bit sloppy for me, so I'm going to stick with log y, and then I'm going to square it, and we're going to integrate that with respect to y because our limits are y. Okay. So that's the integral we're going to carry out. So how do we integrate ln y squared? Well, how do we integrate ln? This is a skill you need from A-level mathematics. We use integration by parts, and there's no different here. It's just that we're going to have to use it twice, but that's fine. So we're going to set u to equal ln y, because we can differentiate it, and that's going to be 1 over y. In this case, the prime is going to be a differential with respect to y. V prime then is the number 1, or you could say it's pi, but we'll leave it as 1. And v then is y itself. Oh, sorry, that is log y squared. So that's going to be 1 over y times 2 log y. Okay, now if we plug those four pieces into our integration by parts formula, then we get that the volume about the y-axis is going to be equal to pi into uv, so that's y times log y squared, and that's between our limits of 1 and e, subtract the integral between 1 and e of v u primed. So the y and the 1 over y are going to cancel, and that's going to leave us with 2 times the natural log of y dy. Okay, now we've got another integral with a log in it, but the power of log has come down by 1, so it was a squared, it's now just a linear in log. So we can use integration by parts again. So I'm going to say u is equal to 2 ln y, which means u primed is 2 over y, v primed is again 1, and v is again y. These are the pieces for this integral, but just be careful because I'm subtracting that integral. Very, very easy to make a sign error, so just be really careful with answers like this. So pi into y times log of y squared, subtract uv, so that's going to be subtract 2y times log y, subtract the negative, so it's going to be a positive. Oh, sorry, there should be a pi there as well. of that times that, which is going to be the integral between 1 and e of 2 dy. Okay. And that's going to equal pi into y times log of y squared minus 2y times log y plus 2y between 1 and e. And these were y limits, so we can now just throw in 1's and e's into that for y. Okay, so plugging in e, ln of e is 1, so that's going to disappear, that's going to disappear. And then ln of 1 is 0, so that whole term will disappear, and that whole term will disappear. So that makes this quite easy. I'm going to leave the pi out the front. I'm going to get y times 1, so that's just going to be e, minus 2e times 1, so it's minus 2e, plus 2e, minus 0, minus 0, and then minus 2. And simplify that, and I'll end up with pi into e minus 2. And that's the answer. That's the volume of revolution of this area being rotated around the y-axis. Okay, and that's it. If you've got any questions, please drop a message in the comments. And thanks very much for watching.